Hello everyone, I am Lin Hui, a PhD student from Paderborn University in Germany. I am happy to give a talk at SOAP about MagpieBridge. The title already says my takeaway for you today: don't repeat yourself and use MagpieBridge for IDE integration. You might already heard about the Language Server Protocol, known as ASP. It is an invention of Microsoft for supporting different programming languages in Visual Studio Code, and it has been widely adopted by other developer tools such as Eclipse, Sublime Text, Vim, and so on. It is used to differentiate between the client, namely the developer tool or the IDE, to the real language understanding engine behind the scene, which provides code actions such as go-to definition, auto-completion, and so on. They put the language server protocol between such that the language server can do the language understanding independently from the client by sending JSON messages forth and back. The client can, for example, send a request to the server saying, I am now looking at a call to a method foo at line 5:20. Please give me the location where foo is implemented. The server will then analyze the source code and send the code location of the method foo back in a response. Obviously, the language server protocol is a good idea, since a language server can talk to any IDE or editor which supports this protocol. MagpieBridge also leverages the language server protocol, and it is a bridge between the developer tools and program analysis. It provides a default implementation of a language server, which we call the Magpie server. It handles all the server stuff one has to do every time when implementing a language server. You can save this work by using MagpieBridge. In addition, MagpieBridge is flexible. It provides a set of APIs such as the interfaces, analysis result, add analysis, which allow program analysis writers to run their analysis on the Magpie server. The Magpie server then converts the analysis result into JSON messages which can be understood by the developer tools. This way, analysis writers don't need to care about the implementation of the UI features or displaying the result in the IDEs anymore. They can focus on writing the analysis better. MagpieBridge provides interfaces to two different kinds of analysis. The server analysis interface is used for analysis which are written in Java. Often they use popular analysis frameworks such as Suite or Vala. For analysis which are not written in Java but have command-line interfaces, the tool analysis interface is designed for them. Next, I want to show you MagpieBridge-based CocoaNeCrypt integrated in the editor Sublime Text. CocoaNeCrypt is a suite-based analysis which detects crypto API misuses. When I play the video, you will see it displays the warnings about crypto API misuses in the editor. And here you see the warnings, and a quick fix will be suggested and applied. Another example is the text analysis engine of FlowDroid. Here you see it is integrated into Visual Studio Code with MagpieBridge. It detects a SQL injection, and the result, including the data flow path, is displayed in the hello message, as you can see here. For command line tools, as I said, MagpieBridge also provides a way to integrate them. Here you see the analysis result of Facebook info displayed in the web editor Gitport. Info is not written in Java but OCaml. So MagpieBridge is a reusable framework, and it provides reusable project services. In order to do whole program analysis writers have to resolve project scope to find the source code path, the library code path. Usually they have to do it every time for every analysis, which is again repeated work. Project services provided by MagpieBridge leverage popular build tools such as Maven and Gradle to solve this problem and save your work, since the resolution is always the same for the same kind of projects. MagpieBridge provides a few implementations which can be chosen by analysis writers. Now I explain how it works. Once the IDE sends the ASP message initialized with the project URI to the Magpie server, MagpieBridge's built-in project services can use this information to resolve the scope of the working project. Computed source code paths, library code paths, class paths can then be used by the analysis. Currently, we already have project services for Java projects, Android projects, and NPM projects. Of course, you are welcome to contribute one and share it with us. The way Magpie server allows analysis to detect issues is instant. It triggers the analysis automatically based on user interactions reflected in the ASP notification sent from the IDE. For example, it can be configured to run the analysis when the user opens a source code file in the IDE, or when the user makes changes to a file, or when the user saves a file. The client which supports ASP provides rich IDE features for diagnostics sent by the Magpie server. You can have markers with different severities, error warning or information, or as you have seen the example for FlowDroid, the witness path for the vulnerabilities is displayed in the hello message. Or some advanced features such as quick fix, as you have seen for CockNeCrypt. Since the first release of MagpieBridge after the ECO paper, we received questions about if MagpieBridge can allow more user control. Some people would like to let the user to control the timing when the analysis should be triggered, or even allow interactions between the user and the analysis. The others would like to allow users or developers to configure the analysis by themselves. Now MagpieBridge can fulfill these wishes. MagpieBridge leverages not only ASP, but also the fact that every computer has a default web browser installed, and we extended the Magpie server to also talk with web browsers in HTTP. The way how it works is as follows. When the Magpie server is started, it will also open a URL in the default web browser. The web browser will show the configuration page for the analysis. This page is generated by the Magpie server from the configuration options and actions defined by the analysis writers through the get configuration options and get configured actions method defined in the analysis interface. The configuration options are displayed in form of checkboxes or input fields, and the actions are in form of buttons. The users can then select the configuration options in this page and submit them back to the server. The Magpie server can then use this information to configure the analysis which has been defined by the analysis writers in the configure method. Afterwards, the user can perform an action in this web page such as run analysis. This action request will be then sent back to the server. The server executes the corresponding runnable task defined for this action in the analysis interface. The analysis will be then triggered. The Facebook info integration actually uses this feature of MagpieBridge. So I want to note here, handling all these back and forth interactions between the Magpie server and the web browser is already implemented in MagpieBridge. As an analysis writer, you just need to define the configuration options and actions within the analysis interface. I hope now you are interested in MagpieBridge. If you want to try MagpieBridge, you can visit our GitHub repository. There you can find tutorials and examples of all these tools I have shown you today. Thank you.